What's going on, everybody? Jesse here. And in this video, I want to talk about using an object class to store your data, then later retrieving that information from that class. So there's many different ways to be able to store information in Unreal. One of the most common ways is probably using the item struct or the struct system, which is, if you're unaware, a struct is just a collection of different variables that you can have, and you can manipulate the information within that struct. You can pass the struct back and forth, but you can't run any functions on that struct. You can run functions and incorporate the struct, but you can't actually run any functions on the struct itself. By doing this in the object class, you're going to be able to see that there is going to be a way that we can run information on the object classes and run functions from those. The only real downside from this, as you're going to see, is we won't be able to actually change any values that are on the object classes. But let's just go ahead and jump right in and let me show you what's going on. So what we have here is, this is just a basic third-person template. I've done nothing special with this. I just loaded this up. So if we push Control Space and we open up our content drawer here, let's go ahead and just create a new blueprint class. Don't worry about selecting any of these content or these common classes here. We don't want any of that. What we want to do is open up the all class and then go ahead and select object. Before I go any further, I want to show you here, if you're not too familiar with the child parent structure, if you notice here, object is the very top thing in this list. This is the parent of essentially every other class within Unreal. It is the core class. So let's just go ahead and select object and then select that. I'm going to name mine BP underscore item underscore P, where for me, P is going to stand for parent. This is ultimately going to be like the grandparent of every other class that I would do within this system. So now that we got that created, let's just go ahead and let's open that up. While we're at it, we're going to come back out here. We're going to end up needing this. Let's just go ahead and open up third person here, blueprints, and open up the character class here. Now, just to give you an example of what I'm talking about with the child parent and the object being the base class. The thing about an object is it doesn't have a lot of overhead, meaning it doesn't have a tick, it doesn't have a begin play, none of these other functions that if you were to come over here on the third person character and look under functions, you see there's 34 overridable functions that you can override here. If I select this drop down, you're going to see all 34 of those. So this class, this character class, inherits here from actor, inherits from character, inherits from pawn. It inherits from all these different classes. By doing this, this creates really kind of an overhead on this object itself, on the character. And the more characters you have in a game, because of all this extra stuff that is in this class, is going to eventually slow down the game. Now, having too many objects in the world, even just base classes, it can slow down your game as well. So with pretty much anything, the bigger a game gets, the bigger your project gets, the slower it's going to run. But the thing with the object class, now we come over here to our BP item P. You can see here the function, there's no overridable classes. If you try to run a tick function on this, there is no tick here. If we go begin play, there is no begin play. This is the bare minimum. So having this, it's not like having an actor in the world where it's going to be ticking every tick and running all these other functions in the background. As a matter of fact, generally speaking, you can't actually spawn an object in the world. Now, there's something we're going to do just a little bit called constructing the class, which is like spawning it in a sense, but it doesn't actually add the object into the world. So let's just go ahead and let's just jump right into it. Under variables here, I'm just going to add a couple variables. The first one, I'm just going to call this one health. Okay, and then I'm going to go ahead and give this a class of float. Add one more variable, name, and then you probably guessed it, I'm going to give it the name type. With these, I'm going to go ahead and go to class defaults here. On health, generally speaking, I would leave the defaults of this class. This is the grandparent class of everything. I would leave these defaults completely blank and let all the children change the defaults. But for this example, I'm only going to make one child of this, so I want to be able to show the difference. So I'm going to give this a default value of 2 for health. And then for the name, I'm going to go ahead and name this base class. So now let's just go ahead and jump right back out here. And real quick, while we're at it, I'm just going to go and I'm going to create a child of the item underscore P. So right click it, select create child blueprint class, and I'm going to name this one BP underscore food. And I'm going to leave it at that. Really, I could have probably put underscore P on there. However you want to do your naming convention, that's fine. This would actually probably be the parent class of every food item that I'm going to have. So from here, I would create children called bread. I'd create a child called berries, a child called water, different things like that, all categories of food, because for the most part, they're going to share common traits like saturation, stamina, things like that. They're going to have very similar things. Let's go ahead and open this up, and you're going to see here in class defaults, we now have the defaults from the parent. We don't see them over here in the variables. You can see them if you wanted to. You can come up here and click settings, show inherited variables, and now you can see them here if you want to be able to do that. But you can just come up here, click class defaults, and you're going to see here, these are the defaults of the parent class. So we can go ahead and change these. I'm going to change this to, let's just say 5, and then I'm going to change the name to food. All right, so now we got our classes that we're going to mess with. So let's go ahead and jump into our third person character. And in here, all this is just the basic functionality of this. We're not going to worry about that today. This really has little to do with what we're going to be teaching. Let's go ahead and right click and type. I'm going to type F key. I'm going to go ahead and use the F key keyboard event. So now every time I press F, it's going to run a function for us. So before we go too far, I want to be able to show you guys exactly what the problem is. And I know almost everybody who's watching this video has ran into this issue before, of where you try to access information from a blueprint and you get access none. If you haven't seen what access none is, go ahead and in the cards right now, I'm posting a link to the video I did on access none. I'm going to go into a little bit more detail in that video, but here, let me just go ahead and briefly touch exactly what that is. So if we come over here to variable, create a new variable, let's just go ahead and call this item, and then we make its type. Let's type item underscore P. There's our BP item P. Select that. So now we did this as, let me show that to you again. I clicked that a little too fast. If we go here and we select the object reference, this is generally what you're going to do when you're creating a reference to something. But remember, an object reference, this is going to be a hard reference. This is what we're going to be avoiding. So when we select this, if we pull this out and get the item, then drag out and we type get health. Well, it says here we can get the health variable that is in the item class. So now if we try to run the function here and get the information from this, let's go print string and take health and plug it right into our print string. So now you would think that this is going to go ahead and give us the health information. So let's compile and save it. Let's just go ahead and run it and see what happens here. Press F. Well, we get 0 up there. Well, we know that there's a value in that. So what happens? Let's go ahead and back out of the game. And we've got a bunch of errors. Every time I pushed F, it created an error. So all these access nones, these are all the same. What this is saying is, hey, you have this object, and I know what this object is supposed to be, but I don't actually have a physical object in the world that I can touch, I can manipulate, and use the information from that. So without having that actual object, I can't do anything with it. That's essentially what it's saying. I've got different analogies that I could use for it, but I won't go too crazy with my analogies. So what do we do to fix this? Well, if you select the item here, you can come over here and it actually shows you that there's actually nothing inside of this variable itself. It says none. So if we were to select this, what can we populate it? Well, you probably could if there was actually an asset of this item type that was living in the world that we can add here, but you can't really add an object into the world without spawning it. And well, since we're not running the game, you can't actually spawn it into the world. So we could spawn an item class in the world, then add it to this variable, then we can manipulate it. But that's a lot going on. And really, as I mentioned a little bit ago, is you can't really spawn an object into the world, an object-based item. You can't spawn that into the world and then grab that object and manipulate it at that point. So what do we do to be able to fix this? Let's go ahead and come over here to the item variable, and we're going to change its type actually. select this one. Select, we go item underscore P. And instead of doing the object reference, I'm going to come down here to class reference. We're going to get this change variable type, yes, because we're using it. You're going to see here, we're going to get this a little bit of information. It's going to tell you that these variables need to be changed. Okay, so we're just going to go ahead and delete this for right now. I'm going to delete all that. So now if we take our item and we pull it out here and we get it, now if we pull off this and we go get health, well, now we can't access that variable health. So what's going on with that? Well, there's actually a different way we would do this from a class. Now we type get default, get class defaults is what it actually is. We select that, and now you can see those variables we created. Now those are accessible. So now let's take this health, plug it in here and into the print string, compile it. Let's go ahead and run this and see what happens. Press F. Well, we still get a 0 up there. So why are we still getting 0? Let's go ahead and back out, and we're getting the same errors that we were getting before. Access none. So why are we getting the access none? What's the point of showing this if we're still getting these errors? Well, the reason why we're getting these errors is the last point I made before we change this object type. If we select the variable and we come over here, you can see that it still says this variable doesn't have any information. It says none. So now if we hit this drop down box, now you can see that everything that is of item type is now available in this list, including our BP food, because it is a child of this class. So let's just go ahead and we're going to select the actual grandparent of this, the item underscore P. Let's go ahead and select that, compile it, and let's run it now and see what happens. If we press F, there you go. Now we get a 2 up there for the value. Let's back out, and beautiful. We don't get any access nones. Just to show you the difference here, let's go ahead and grab the BP underscore food and go ahead and run it again. Press F, and there we go. We got the values from the food. It shows a 5 in there. Just one last example here. Let's go ahead and delete this. Take the name, plug that in here into the print string, run it, press F, and it shows that we have a food item within this object or within this variable. So now, what else can we do with this? Right now, we're not really doing much more than what a struct can give you. See, I can't actually go in right now and I can't set this value. I can't set health on this variable. It's a static class that is not an object in the world, so we can't manipulate its data. So really, what good is this to us at this point? At this point, well, it still can be pretty easy for you to be able to follow and have a structure within your system. For example, my base class, the grandparent class, the item underscore P, that one would probably have the main base information that all the items would have, like a static mesh, a thumbnail, and just some other base information that every item is going to have. And then we get more granular the more children we have as we get deeper down into everything. So what do we need to do to be able to kind of extend this and get this to go further? Well, one of the reasons why you might want to do this is because in something like this, where this can be used for, say, an inventory system, almost every game you have is going to have some sort of inventory system where you're going to have to track a bunch of different items. In a particular inventory system, those items that you have are going to be, you're going to be able to use those items, right? You want to be able to use them, but how do you use it? If you just have something like a struct, that means you're going to have to check that struct. You're going to have an extra variable within that struct to tell it what kind of object it is, and then you're going to have to run a switch to be able to define a different function that you want to run for every single different class that you have. Whereas with this, it's a little bit more readable, a little bit easier to follow, where you can go and you can put a function on a particular class and have it run its own function. So let's go in here, and under our main grandparent, the item underscore P, what we're going to do, since this is the grandparent that everything else is going to inherit from, let's go ahead and click function, and we're going to name this function use item. Okay, and normally with a grandparent class, with your main class, you don't want to really do anything with it. If there's something with every single item, if you want to do the exact same thing when you use every single item, then you put that in here. But generally speaking. The reason why we're doing this is because not every single item will be used the same way. It's going to have different things. You know, food's going to add saturation to your health. It's going to add, you know, maybe stamina, whatever else you want it to do. Whereas in like a weapon, when you use a weapon, it's going to deal damage. So you're going to have to handle that a little bit differently. The only thing that I would suggest doing here, what you might want to do is pass inputs into here, because you're not going to be able to access things like the player character like you normally would. So normally you could be able to type get player character, and it will default and give you the player character within the world, and then you can cast from that, or you can run an interface function on that class. But here you can't, because again, this is a base object class. It doesn't have any of that information, so you can't get that from here. It doesn't have this function. So in order to get the player character, one of the things you can do is you can go ahead and on the input, you can go ahead and type player, or you could do it a different way. You could just type actor, because, you know, really in the long run, it may not be the player who's going to run use every single time. It might be an actor. So you might just want to do an actor, you know, name it player, and then go type actor, and then make it the actor object reference right here. But we're not going to do that right now. I'm just going to go ahead and make this third person character, just so it's a little bit easier. Do an object reference. So now we need to pass this in. By doing this, we don't have to do any casting or anything like that. So let's go ahead and do a return node on this. And like I said, generally speaking, this is it. This is about all you want to do. Maybe add some more inputs if you think you might need them for other classes down the road, but you don't have to do it right here, right now. But what we're going to do, since we only have two, I'm going to, just to show that there's different functionality with this, I'm just going to go ahead and print a string with this, and we're going to say from base class. That's all we're going to have it say. Okay, so let's go ahead and compile and save this. Now our child should be able to have this. Now if we come over here to the BP food and we look over here in the functions, you're going to see now we have one overridable function, and now we got this drop down list. We select this, we can override the use item. So if we select this, opening up the function is going to give us an immediate function here to be able to run the function from the parent, and then we can add our own function at the end. But we don't want to do that with this particular instance, right? We don't want this to say this is from the base class and then do whatever else we're going to do here, because this isn't from the base class. We don't, at this point, we don't really care what the parents do. Now if we had a bunch of functionality within the parent class that we wanted to inherit from, that we wanted this one to run, then yes, we would go ahead and leave that function call in there and then add our information. But in this example, we don't need it, so I'm not going to worry too much about it. So let's go back here real quick to the third person character. I want to add an extra variable here, and we're going to just call this one health. We're going to go ahead and make it a float type, and we're just going to leave the default at 0. It doesn't really matter at this point. So the default of the player health is 0. All right, so let's go ahead and jump back into BP food. From BP food now, if we come down here and we grab our player character, we can go ahead and do get health. We can get access to the health variable here, and then drag off of this, hit a plus, add, and then we come over here and we don't see those variables in here. I showed you just a little bit ago. We can go ahead and right click this if we want and do show inherited variables, and then we can take this out and just drag it out. If you don't want to do that, then just simply right click and go get health, just like you would any other way. Select this, and now you have the health variable of this class, and drag that in here. We're going to add these two together, and then we're just going to go ahead and we're going to set the variable back on the player, set health, and we're going to set it to this new added value that we got here. So now it's going to take our player health and it's going to add the class default, which is 5 for this, and then that's it. It's going to go ahead and just keep adding it up every time we press F. Hit the return key or return node and go ahead and compile this and go ahead and save it. So now if we go back into our third person character, we come down here and let's just go ahead and delete the get defaults information. We'll leave the print string for now. So now if we drag off of this class, we go use item. Well, our function's not there. So what do? Well, what you got to do actually is we type construct object from class. Like I said earlier, this is essentially spawning the object into the world. And if you hover over it, you're going to see it says here attempts to spawn a new object. So it's actually going to take this object and technically it's going to spawn it into the world, and which is very similar to spawn actor from class, except for this doesn't actually add a physical object into the world. An object, a base object, can't really belong in the world, but it's going to spawn it to the point to where it does make it an object living within the engine that you can go ahead and manipulate from that point. And really you could take this right here and you can store this and put this in a variable. So if in our original example here with the item class, we could actually change this to be the object reference and then store this into that, and then you can manipulate that variable that way. So you could technically do that. This is almost like if you cast a variable type and then you save that cast object, like when you're casting to your player character, your player controller, and then you save that reference for you to use later. That way you don't have to keep casting to an object because casting it can tend to be expensive, especially when you do a bunch of it in a row, like in a tick or anything like that. But this will be fine to run if you do it this way, as long as, like with casting or any other spawn in the world, you don't want to put it inside of a tick. In our particular use case, in this inventory type system, this isn't something that would be used too often. If you use an item, you're going to use one item at a time. You may use a whole bunch of items rapidly in succession, but eventually those items are going to run out. The function is going to be able to not work anymore because you no longer have that item. So I'm pretty confident in doing this, that it's not going to create a whole lot of overhead. All right, so now if we drag off of here and we type use item, now we've got the function in here that we can go ahead and do. And it's asking for a player here, so let's just go ahead and type self, get a reference to the player character itself, plug it in there, and then we go ahead and print string. So what are we going to go ahead and print? We're going to pull out our health variable right here, and I'm going to go ahead and type format text, and in this format text I'm going to type the word health and a colon, and then in curly brackets I'm just going to write health and then close it in the curly bracket. What that's going to do is that's going to give me the option to add a pin here. So I'm going to take this, it's grayed out because it doesn't have a particular variable type until you plug into it. So I'm going to plug this, and now it's going to turn that into a float inlet. So now we're going to take this result from the format text, plug it in there, it's going to convert it to a string, and now we're going to get information from the health into the format. And remember, our current item is as food. So go ahead and play this, and if we hit F, you can see our health is now going up by 5 every time I press the F key. Go ahead and hit escape and exit, and we get no errors. So now if we just show you how this works, if we come back here to the item, we can change this to the parent, the item underscore P. Let's go ahead and compile it and then hit run, press F. Now we just get, because we're not adding any health to it from there, the parent class is just printing from the base class, not doing anything else. Exit, and there you go, no errors. So as I said, in Unreal, there's many different ways you can be able to store objects. It's ultimately going to be up to you and your project and how you want to run it. I kind of like this structure because it's a little bit easier. We're comfortable for the most part with blueprints and how the blueprints work. So to have it here like this makes it a little bit easier. Sometimes data tables, especially when you have hundreds or maybe even thousands of different items or objects that you're trying to account for in the world, a data table can really get big and cumbersome. Really, so can your object classes. But I think visually, for at least me, when I look at an object class in a place like this, it's easy for me to be able to say, okay, here's the variables. What are the defaults of it? I need to change the defaults of it. If I need to add a special variable here, so since this is food, maybe we'll add saturation to it, right? And we'll change this. So now this is a special variable on any of the food classes that's not available to the item class. There is nothing here because this is the parent. Parent doesn't inherit from the child. So you can add more to it. So it's a little bit more visual. And then on top of it, you get the added benefit of being able to have functions. Now, I wouldn't recommend running too many functions on this because it's just going to defeat the purpose of the object class. If you need to run a whole bunch of functions, then just create an actor. If you need to disable tick on the actor to save some overhead, then go ahead and do that. That's easy to do. It's just a little checkbox in the class settings. But generally speaking, just use a couple basic functions in here. That would be fine. But you can't manipulate any of the variables on here. So we can't dynamically change the health value from 5 to 20 while the game is running. It's just not going to know what to do with that. So the class default is a hard default that you're going to be able to access. So in this case, you could see here what we're doing is we're actually getting the reference to the player, and then we're setting the variable on the player. Technically, what I would do in this situation was I would put a add health or something function on the player character, and then from here just call that function on the player itself, or more correctly, I would run an inherited function on that class, and then that way that class can handle it itself. So we'll go into a little bit more depth. Like I said, the next series I have is going to be an inventory control series that we're going to get into, and I think I'm going to go ahead and code it like this. I originally didn't code it. I used the item struct function for the blueprints, but I think I'm going to go ahead and refactor it. I'm going to change it to use this system. This is the system I used when I originally designed it in C++, and I really kind of liked it there. Getting object references in C++ is a little bit easier than it is in blueprints, and if we end up doing some C++ tutorials, then I'll show you that. But for now, I hope you guys got this, and if you have any questions, go ahead and leave your comments down in the down below, or you can jump over into the Discord and ask your questions there, and I'll be happy to answer. Until the next video, thanks for stopping by. Have a good one.